The Flex4RES project analyzes flexible Nordic and Baltic energy systems. This video presents results for Norway. Let's first have a brief overview of the scenarios applied in this study. Business as usual lets the energy system progress according to the Nordic energy technology perspectives, carbon neutral scenario, and NSOE's 10-year network development plans. The Connect scenario allows for additional expansion of transmission, while the policy scenario eliminates regulatory barriers in form of volumetric taxes and tariffs on electricity, exchanging them with capacity-based ones. This is intended to enable more flexible use of electricity. And finally, the Combi scenarios combines the policy and Connect scenarios. Looking at the key findings for Norway, the additional investment in transmission allowed in the Connect scenario leads to a significant increase in transmission. Subsequently, this also leads to increased electricity exports from Norway. The business case for Norwegian wind and hydropower generators improves significantly with increased interconnection. This can be seen in the green areas, indicating an increase in revenue compared to the business as usual. Consequently, price increases are seen as electricity is increasingly traded with Norway's neighboring countries. All scenarios show Norway to become quickly decarbonized, with large participation of hydropower, and as an electricity exporting country. Now let's look at some results in more detail. We start out in the electricity sector. Norwegian taxes and tariffs have relatively small impacts on capacities. Similarly unchanged is the hydropower capacity, with a share that remains fully utilized across all scenarios. And finally, wind and, to a small degree, CHP capacity is positively impacted by the increased transmission. The increased wind capacity leads to increased wind-based generation as well, but hydropower remains by far the largest source of electricity in all scenarios. Now, the district heating sector. All scenarios show a reduction in heat generation capacity due to assumed increased efficiency in operation. For CHP, increased transmission leads to increased capacities, while power to heat becomes slightly less attractive due to the increase in electricity prices locally, even despite the improved electricity taxes and tariffs from the policy scenario. Waste continues to make up a significant share of Norwegian heat supply, while the shift to heat pumps in power to heat results in decreased fuel use in all scenarios. Finally, we see gas use phased out from 2040. Moving to storages, we see that seasonal heat storage capacity is fully utilized in all scenarios. For short-term storage, the Combi scenario shows a particular synergy between increased transmission and improved taxes and tariffs. This can be ascribed to the increased capacities of CHP as well as heat pumps, which can utilize the heat storages for short-term operational optimization. You can find similar videos with country profiles and recommendations the same place you found this one. For even more details, have a look at flex4res.org.